Welcome to this explainer. Okay, today we are unpacking a truly fascinating paradox. We're looking at why making reading physically easier and seemingly frictionless on a digital screen might actually make our cognitive understanding much, much shallower. We live in an age where interfaces are designed to be just as smooth as glass. But today, we're going to look at the hard science and some really surprising design philosophies that suggest we might actually need friction to truly learn and understand something.
Here's our roadmap for today. We're starting off with the mechanics of ocular fixation, moving into the digital reading deficit and haptics and the physical book. Then we'll pivot to roguelike games and semiotic friction, explore the frustration aesthetic, and wrap it all up with mastery through mental simulation. Let's dive right in.
Section 1. The Mechanics of Ocular Fixation. So first things first, reading is not just this abstract mental activity. It is a profoundly physical, embodied act. Ocular fixation is the literal biological mechanism that anchors our interaction with any text. It's that period of relative stillness when your eye actually physically pauses to acquire data. When you read, your eyes definitely don't glide smoothly across the page like a cinematic camera panning across a landscape. Instead, they operate in these jerky staccato bursts, physically stopping to ingest the visual data of the words.
And to put that into perspective, these rapid fixations last just 50 to 600 milliseconds, literally fractions of a second. These tiny pauses are interspersed with extremely rapid jumps, called saccades, which span just a few character spaces at a time. So what this means is that your mind is actively peeping at language through a very narrow, highly mechanical visual portal.
Section 2. The Digital Reading Deficit. Now, what happens when we take that physical eye movement and put it on a screen? Well, the crucial point here is the massive difference in cognitive load. Print media has a stable material presence. The text doesn't move. This gives your brain a very low external cognitive load. But digital text? Totally different beast. It's a stacked symbolic abstraction, or what researchers call a flickering representation. The screen dramatically increases our external cognitive load because we have to navigate, click, and scroll. It completely disrupts the stable, bounded focus we naturally get from physical print.
When we break down this ontological split, you can see how print operates on a really simple this is this referential logic. The ink is right there. But the digital screen is this is that. It's a temporary representation of underlying code. This flickering screen representation requires constant subconscious mental navigation from you. And what does that do? It constantly drains your working memory resources. Instead of using your brain power for deep semantic comprehension, actually understanding what you're reading, you are literally wasting it just managing the interface.
But hey, don't just take my word for it. To prove this, cognitive scientists conducted an incredible study testing middle schoolers reading on print versus reading on digital screens. They hooked them up to track an electrophysiological brainwave called the N400 ERP. Now, the N400 is basically a biological index for how deeply your brain is processing meaning and semantic integration. Basically, if your brain processes a word deeply, it fires off a strong signal and builds a robust semantic network.
Now, look closely at the data for what the researchers called chimera words. These are moderately related words that require a bit of deep thought to connect to the rest of the text. The data shows that digital readers process these chimera words as if they were entirely unrelated. Their brains literally failed to make the deeper connection. This is hard neurobiological proof that screens cause a shallow semantic encoding deficit. They were reading the words, but the deep meaning was just bouncing right off them.
Section 3. Haptics and the Physical Book.
This idea perfectly summarizes why paper just works. Remember, reading is an embodied activity. The haptic feedback, the literal touch of the paper, the tactile resistance of turning a page, even the physical weight of a book in your hands. All of that provides your brain with stable, physical anchors. You subconsciously map where a piece of information is physically located. Like, oh, I remember that happened halfway down the left side of the page. Those physical coordinates create self-conscious reflexivity and lay down much deeper memory traces.
Which naturally brings us to a really fascinating question. If smooth, frictionless screens strip away our physical anchors and make our thinking shallower, well, can we intentionally reintroduce digital friction to reverse this cognitive deficit? Basically, if easy equals shallow, can we design hard interfaces to force deep encoding?
Section 4. Roguelikes and Semiotic Friction. To answer that, let's look at games like NetHack, or Ancient Domains of Mystery. These games absolutely do not use modern high-definition graphics. Instead, they use a purely text-based ASCII interface.
This introduces extreme semiotic friction. It completely shatters our standard visual expectations by forcing players to decode the character mapping themselves. For example, they use literal classing, where a lowercase d represents a dog. Pretty straightforward, right? But then they use complex relational classing. A lowercase h represents a small humanoid, like a dwarf, while an uppercase H represents a giant. You have to actively translate the text into a visual world in your own mind.
Section 5. The Frustration Aesthetic.
Now, designers of these games utilize what is called a frustration aesthetic. By making the interface super confusing and difficult to parse right off the bat, it completely prevents passive consumption. You absolutely cannot just zone out and scroll like you do on social media. The interface forces the user to work incredibly hard just to comprehend basic spatial layouts or to figure out what kind of monster is standing right in front of them. It demands the exact kind of active cognitive mapping that we lose when we're casually reading on our modern frictionless tablets.
Section 6. Mastery through mental simulation.
So what's the payoff for all this frustration? By forcing players to struggle through this semiotic disorientation, the game demands mental simulation. This is the bridge between a wildly abstract text interface and profound cognitive mastery. Your brain works so intensely hard to decode the symbols that it begins to lay down incredibly robust, deep semantic networks. It's the exact opposite of the shallow processing we saw in those middle school brain scans. We can actually look at how this builds using the philosopher Martin Heidegger's framework. At first, the interface is present at hand, meaning it's confusing, it's obtrusive, it's just a bunch of random letters on a screen causing massive conscious cognitive friction. But through forced effort and repetition, the interface undergoes what is called intentional disclosure, becoming ready to hand. Eventually, the player's brain processes the information so deeply that they no longer consciously see a green letter G. They immediately, unconsciously perceive a hostile goblin. The friction has literally forced total, transparent mastery of a highly complex system.
Contrast that incredible hard-won mastery with our modern touchscreens. The perfect, user-friendly graphic interface is really, at the end of the day, just an empowering obfuscation. Actually, scratch that. It's more like a mask. It hides the underlying complexity of the machine, giving us this lovely illusion of control, while actually rendering us passive, shallow consumers of flickering lights. We aren't mastering the system is managing us.
So I want to leave you with this provocative thought to consider the very next time you are effortlessly scrolling a newsfeed or tapping on a perfectly smooth piece of glass. If the neurobiology shows that friction creates deep encoding, and the brutal design of roguelikes proves that cognitive struggle yields profound mastery, shouldn't we demand a little more frustration from our digital lives? Thanks so much for joining me on this explainer, and I challenge you to go out and find some friction today.